Hello, namaste to everyone. You are watching Big Physics YouTube channel. Today I have come up with new video on CG coefficient or class-based Gordon coefficient. In this video, we discuss how CG coefficients can be calculated and how this concept was introduced. In short form, we also describe addition of two angular momentum. And if you are new to this video or to our YouTube channel, please subscribe our YouTube channel because your one subscription is 100 times most powerful motivation to us. And to understand this video clearly, please watch it ends. Okay, now let's discuss about today's topic. Here, we go for addition of two angular momentum first, because to discuss about CG coefficient, we need to discuss about addition of two angular momentum. Okay, at first, हामी के गरौँ भने दुईवटा पार्टिकल लिम जसको स्पिन S1 and S2 छ, अथवा यसलाई हामी इन्ट्रिन्सिक एंगुलर मोमेन्टम भनेर पनि भन्छौं। र तपाईहरु S1 र S2 लाई J1 र J2 ले पनि रिप्लेस गर्न सक्नुहुन्छ। अब हामीले चाहिँ यिनीहरुको बिहेभियर अथवा यिनीहरुको वेभ फंक्सन थाहा पाउनको लागि चाहिँ हामी S1 र S2 लाई फर्स्ट डिफरेन्टली ट्रिट गरौँ र कम्प्युटेसन रिलेसन फाइन्ड आउट गरौँ। S1 र S2 को कम्प्युटेसन रिलेसन कसरी सेटिस्फाई हुन्छ र हामीले कम्प्युटेसन रिलेसनलाई हेर्ने हो भने S1 स्क्वायर र S2 स्क्वायर कम्युट गर्छन्, S2 स्क्वायर र S1Z कम्युट गर्छन्, S1Z S2Z कम्युट गर्छन् एन्ड सो र तपाईहरुले एउटा सेट पाउनुहुन्छ S1 स्क्वायर S2 स्क्वायर S1Z S2Z यी अपरेटर्सहरु कम्युट गर्छन् पेयर बाइ पेयर, so that this set forms complete set of commutating observable. This means that these all operators or S1 square, S2 square, S1Z, S2Z all have some common eigenvector. They can be described by some common eigenvector or they can be expanded in terms of some common basis function. Now our task is to define that common basis function. So let's define that common basis function by this way. Here the basis function is defined by S1, S2, M1, M2. In short form, we can define this by M1, M2. Here S1 and S2 is excluded because S1 and S2 are fixed for given system. So that this is the basis function for the complete set of commutating observable this. Now we add these two angular momentum now as this. Okay, अब हामी चाहिँ जब S1 र S2 लाई एड गर्छौं र नयाँ स्पिन पाउँछौं, नयाँ मोमेन्टम एंगुलर मोमेन्टम पाउँछौं, that is S. र अब हामीले फेरि कम्युटेसन रिलेशनशिप गर्ने भने we find different result. Here S square commutes with S1 square, S square commute with S2 square, but S square does not commute with S2Z and S1Z. This means that S square, S1 square, S1Z, S2Z cannot have some common eigen basis function. But if we define SZ by S1Z and S2Z and seek the commutation relation with S square, they commute like this. Here S square commute with SZ. This means that the set S1 square, S2 square, S square, SZ also form complete set of commutating observable. They also can be described by some common eigenvector or some common eigen basis function. So let this define or let this common eigen basis defined by this basis function. Here the basis function is Sm. This is new basis function which is totally different from previous one. Okay, here we have got two important results. Two basis CSCO set and two basis system. One is M1, M2 for S1 square, S2 square, S1Z and S2Z set, and this is called old basis system, and another system for this basis system. Now addition of angular momentum means that we need to find the relation between these old basis system and न्यू बेसिस सिस्टम कोएफिसिएन्टहरु भनेको के हो र यो कसरी क्याल्कुलेट गर्ने यसलाई हेरौँ है त सीजी कोएफिसिएन्ट भनेको हामीले एडिसन दुईवटा एंगुलर मोमेन्टमलाई एड गरिसकेपछि हामीलाई एउटा दुईवटा बेसिस सिस्टम आउँछ र हामीले एउटा ओल्ड बेसिस सिस्टम भनेर डिफाइन गर्यौं र एउटा नयाँ बेसिस सिस्टम भनेर डिफाइन गर्यौं हाम्रो ओल्ड बेसिस सिस्टम यो थियो भने नयाँ बेसिस सिस्टम यो थियो तर हामी के गर्न सक्छौं भने न्यू बेसिस सिस्टमलाई ओल्ड बेसिसको रूपमा एक्सप्यान्ड गर्न सक्छौं अथवा लेख्न सक्छौं by this way हामीले दिस फर्मुलाबाट चाहिँ अथवा दिस रिलेसनबाट हामी ओल्ड बेसिस सिस्टम र न्यू बेसिस सिस्टमलाई कनेक्ट गर्न सक्छौं by introducing such a term here this is a term the term introduced here this is called CG coefficient or these represent the CG coefficients भनेर हामी भन्न सक्छौं है त हामी भन्छौं अनि त्यसपछि अब हामीलाई के छ भन्दाखेरि चाहिँ this is simply the scalar product of the two basis system so to define CG coefficient are just nothing, they are real number that gives the proportional relation between new basis and old basis in the given state when we add or when we deal with the problem addition of two angular momentum. Here now let's discuss how to calculate or what are rules to calculate CG coefficient. Here is the first rule, selection rule. The CG coefficient term, this will term equals to 0 if capital M equals to M1 plus M2 and this relation are not satisfied at the same time. यदि यो रिलेसन र यो रिलेसन दुईटै एकैचोटी सेटिस्फाई भएन भने यो टर्म 0 हुन्छ अनि हामी अर्को रिलेसन छ अर्थोगोनल रिलेसन यदि हामीले दुईवटा फरक ओल्ड बेसिस M1 M2 फरक लिएको हामीले स्केलर प्रोडक्ट लिने हो भने त्यसको टर्म यस्तो हुन्छ हामीलाई यो स्केलर प्रोडक्ट रिलेसन हामी सबैलाई थाहा भएकै कुरा हो र यो दिस भ्यालु इक्वल्स टु 1 इफ M1 equals to M1 prime and M2 equals to M2 prime otherwise this term will be 0 and अर्को हामी रिकरेन्स रिलेसन छ रिकरेन्ट रिलेसन चाहिँ हामी पछि डिस्कस गर्ने छौं अब चाहिँ हामी सीजी कोएफिसिएन्टहरु चाहिँ एउटा स्पेशल केसमा डिस्कस गरौँ कि सीजी कोएफिसिएन्टहरु कसरी क्याल्कुलेट गर्ने भनेर है मैले चाहिँ S1 equals to half and S2 equals to half को केसमा सीजी कोएफिसिएन्टहरु लिएर क्याल्कुलेट गर्दै छु र त्यसलाई चाहिँ कसरी एड गर्न सकिन्छ जस्तो यहाँ दुईवटा एंगुलर मोमेन्टम छ स्पिन हाफ एन्ड अनदर पार्टिकल को स्पिन पनि हाफ छ यो दुईवटालाई एड गर्यो भने हामीलाई कस्तो रिजल्ट आउँछ र सीजी कोएफिसिएन्टहरु कसरी क्याल्कुलेट गर्ने त्यसलाई हेरौं जस्तो हामीसँग यहाँ S1 छ S1 भनेको इन्ट्रिन्सिक एंगुलर मोमेन्टम और स्पिन अफ द फर्स्ट पार्टिकल हाफ छ भने यससँग एसोसिएटेड म्याग्नेटिक मोमेन्ट को भ्यालु चाहिँ हाफ एन्ड नेगेटिभ हाफ हुन्छ हामी सबैलाई थाहा छ M1 runs from -S1 to +S1 स्टेप बाइ +1 एकले डिफरेन्स हुँदै -S1 देखि +1 सम्म यसको भ्यालु हुन्छ सिमिलरली वी क्याल्कुलेट S2 को भ्यालु पनि 1/2 M2 को पनि 1/2 र नेगेटिभ 1/2 हुन्छ त्यस्तै अब दुईटैलाई एड गर्यौं भने हामीले चाहिँ टोटल स्पिन 1 हुन्छ र एसोसिएटेड म्याग्नेटिक मोमेन्ट क्यापिटल M को भ्यालु 1 0 -1 हुन्छ है यो सबैलाई थाहा भएको कुरा हो यु क्यान इजिली क्याल्कुलेट दिस नाउ नेक्स्ट स्टेप वी हैव टु डू इज to calculate or to find out the possible state space in the given state space दिएको state space मा कतिवटा possible state हरु हुन्छन् that is calculated by this is the absolute value of S1 plus S2 S1 plus S2 minus 1 and so on S1 minus S2 if we put the value of S1 and S2 here we get 1/2 plus 1/2 1 1/2 plus 1/2 minus 1 0 and so on and 1/2 minus 1/2 0 so here the possible results are 1 and 0 hence given state space we have total possible state space are S equals to 1 and S equals to 0 now consider subspace S equals to 1 having this combination you can make this basis system as like this for example 1 here the S को भ्यालु 1 छ भने M को भ्यालु कति हुन्छ हामीले अलरेडी भनेका छौं -1 0 1 so 1 may be combined with 1 may be with 0 or 1 may be with -1 so possible states are given by this again consider another state space subspace that is S equals to 0 in this case the value of S is 0 so value of capital M equals to 0 so only possible state is 0 0 now let's arrange this term in the table like this way here I have arranged the table like this way here S1 1 1 0 1 m भनेको 1 0 0 -1. Here I have arranged this term in descending order. First positive number and lowest positive number and then negative number. Okay, and here I have arranged m1 and m2 in this way. 1 by 2, 1 by 2, 1 by 2 minus 1 by 2. Now next on 1 minus 1 by 2, 1 by 2, minus 1 by 2, 1 by 2. Okay, after arranging the table in this way, use the rules to find CG coefficients. Okay, हामीसँग फर्स्ट रिलेसन के छ भन्दाखेरि चाहिँ यो छ, हेर्नुस् है, S1, S2, M1, M2 with SM equals to 0. If M equals to M1 plus M2 भएको छैन भने है, यहाँ हेर्नुस्, M1 यहाँ छ, M2 यहाँ छ, यो प्लस यो गर्दाखेरि यहाँ M को भ्यालु भएन भने टर्म 0 हुन्छ. 1 by 2 plus 1 by 2 त 1 हुन्छ, यहाँ 1 हुन्छ, त्यसैले यो टर्म 0 भएन. अब यहाँ हेर्नुस्, 1 by 2 plus 1 by 2 1 हुन्छ, तर यहाँ M 0 छ, त्यसैले यो टर्म 0, यो पनि 0, यो -1 छ, यो पनि 0. किन 0 भन्दाखेरि चाहिँ यो दुईटैलाई एड गर्दाखेरि हाम्रो 1 भइराछ, तर यहाँ M को भ्यालु कति छ त 0 छ भने यसको करस्पोन्डिङ सबै के भयो 0 भयो. त्यसैले त्यस्तै सेकेन्ड केसमा हेर्नुस्, -1 by 2 plus -1 by 2 कति हुन्छ 0 हुन्छ. M 0 भयो, टोटल M 0 भयो, तर यहाँ 1 छ भने यो पनि 0 भयो, यो पनि यहाँ यो, तर यो केसमा 0 भएन किनकि यहाँ 0 छ, त्यसैले यो पनि एड गर्दाखेरि 0 भइराछ भने यो दुईवटा केस 0 भएन, र यो पनि त्यस्तै 0 किनकि यहाँ -1 छ, यहाँ जोड्दाखेरि 0 भइराछ. त्यस्तै यसमा पनि यो भएछ, -1 by 2 plus 1 by 2 0 भयो, तर यहाँ 1 छ, त्यसैले यो टर्म 0. These two terms are not 0, and this also 0. Again, this similar case to this. Again, if the only one possible combination, for example, we have M equals to M, capital M equals to 1 छ, र हामीसँग M1 plus M2 एड गर्दाखेरि एउटा मात्रै स्टेट छ, जस्तो कि 1 by 2 plus 1 by 2 गर्दाखेरि मात्रै 1 हुन्छ, अरु कुनै पनि टर्मले 1 दिदैन भने हामी सिम्पली एउटै मात्रै लिनियर कम्बिनेसन अथवा एउटा मात्रै पोसिबल स्टेट सब स्टेट भएकोले त्यसको ठाउँमा हामी सिधै के गर्न सक्छौं 1 राख्न सक्छौं है. यहाँ पनि 1 राख्न सक्छौं अनि यहाँ पनि 1 राख्न सक्छौं. यहाँ पनि त्यस्तै एउटा मात्रै छ, -1 by 2 plus -1 by 2 -1 हुन्छ, यो केसमा मात्रै हुन्छ, अरु केसमा हुँदैन. त्यस्तै अब दिस टर्महरु चाहिँ के हुन्छ भन्दाखेरि चाहिँ जस्तो 1 by 2 -1 by 2 पनि 0 भइराछ, हामी किन 1 राख्न सक्दैनौ यो केसमा भन्न क्वेशन हुन सक्छ. किनभने यो जे यहाँ पनि यो पनि 0 भइराछ, यो पनि 0 भइराछ भने यो स्टेटको लागि त यो दुईटैको लिनियर कम्बिनेसन हुने हो भने अब कस्तो छ त कोएफिसिएन्ट कन्स्टेन्टहरु के हुन् हामीलाई त्यो थाहा छैन. त्यसैले यो केसमा हामी के भेरिएबलहरुले पुट गरौँ. लेट्स राइट दिस इक्वेसन बाइ भेरिएबल by this A, B, C, D. Now our task is to find A, B, C, D. These are the CG coefficients. Here 1, A, B, C, D, and 1 are CG coefficients. You have to calculate this. Now we have one important relation here. How to calculate them? Okay, let's discuss. Now, when you multiply using second relation, orthogonal relation, when you multiply A times A and C times C and adding, the result will be 1. For example, A into A plus into C1, A into A plus B into B equals to 1, B into B plus D into D equals to 1. Multiplying with same and adding both together gives 1, that is orthogonal relation. But multiplying one with another and adding will give 0. For example, A into C plus B into D equals to 0. A into D plus B into C equals to 0. Like this. This is the rule. You can calculate or you can find any relation. You need to 4 relation to solve them. I take this. Let's see. A square plus C square equals to 1. B square plus C square equals to 1. One cross multiplying also you will get 1. You can multiply in this way. And you can also multiply in this way. Like A times A square, A times A square plus D times D square gives 1. Okay. Now next, another relation. A into C plus B into D. Here the M1 and M2 are different. So their on multiplying and summing, their term equals to 0 here. Okay. Because M1 and M2 are not same. So what will have delta m1 and m1 prime equals to 0 because m1 and m1 prime are not same. Similarly, I can take another relation AD plus BC equals to 0. In this way, we can make so many equations, and we only need to solve 4 equations to find these unknown. So I have take these 2 equations. This equation, on subtracting, you will get B equals to C because A square minus A square get cancelled. I take another relation AC plus BD because you already know B and C. So on substituting, you will get relation between A and D. So A is negative D. Okay, after substituting, okay, we have to again find the relation between what? This equation. Okay, let's do. On substituting B equals to C and A equals to negative D in this equation, you will get B equals to C equals to 1 by root 2 because here B plus C, you can substitute here value of B or C, then you will get this result. And on substituting value of A equals to negative D in this equation, you will get A equals to negative D equals to 1 by root 2. So in this way, you will find B equals to C equals to 1 by root 2 and A equals to negative D equals to 1 by root 2. Hence, we have all find CG coefficient here in this way. You can easily find in this way the CG coefficients. Okay, now let's make linear combination, or let's add this angular momentum by in this way. First example here, linear old new basis system SM 1 1. This is the only one possible state. 1 by 2 1 by 2 having CG coefficient 1. So here is 1. Okay. Next 1 0. 1 0 is the linear combination of the two states. 1 by 2 minus 1 by 2 and minus 1 by 2 plus 1 by 2 having CG coefficients 1 by root 2 1 by root 2 like this. This is state 1 by root 2 common. And similarly, you can have 1 minus 1. 1 minus 1, only one possible state, 1. So there is a CG coefficient 1. Okay, our next state 0 0. Here 0 0 state is also linear combination of the two state, this M1 and M2 this state. So I write this having CG coefficients 1 by root 2 minus 1 by root 2. In this way, you can add and find CG coefficients easily in shortcut method. Thank you. And in the next video, I will describe how to calculate CG coefficient in case of angular momentum 1 1. Thank you for watching.